Hello, and welcome to this presentation introducing a framework for a cross-disciplinary STEM core, an initiative of Preparing Technicians for the Future of Work, a project funded by the National Science Foundation's Advanced Technological Education Program. Preparing Technicians for the Future of Work is facilitating cross-sector dialogues between community colleges and industry on the new fundamentals of technician education. By acting on input from educators, employers, and economic development professionals about the adoption of advanced technologies and the associated new knowledge and skills needed to use them, the project team has developed recommendations for addressing these topics without overburdening college technical programs. I'm Anne Claire Anderson, the principal investigator for the project, and here is the project team. As a project, we are focused on transforming two-year technical programs in ways that ensure graduates are prepared not just for today's jobs, but for tomorrow's. Here are the goals for preparing technicians for the future of work. As you can surmise from Goal 4, foster adoption of the cross-disciplinary STEM core to maximize impact on technician education, the project has developed recommendations for community college technical programs that I will outline a little later. The global workplace is evolving right before our eyes. Advancements driven by cutting-edge technologies are transforming existing industries and creating new ones. Even before COVID struck, we recognized that the pace at which society and technology are changing is accelerating like never before, and we have to keep up so that our students will thrive in the new economy. Today's technicians are cross-disciplinary workers, immersed in diverse platforms and interrelated systems that once belonged to a single industry sector. While demand for positions involving tasks that can be automated is declining, new occupations are emerging. The skilled technical workforce sits at the center of this disruption. Industry 4.0, the fourth industrial revolution, the digital transformation of manufacturing and production industries, means that smart machines are getting smarter, and production, assembly, monitoring, and maintenance in a wide variety of industrial settings are becoming more efficient. So how does this change a STEM technician's role? The transformation of the workplace means that America's technicians will need to navigate and troubleshoot processes involving artificial intelligence, the Internet of Things, cybersecurity procedures, advanced robotics, digital design and prototyping, and the way in which these and other advanced technologies interact within horizontally and vertically integrated systems. As we think about technologies and technicians of the future, here are a couple of things to keep in mind. Technology eliminates job categories, not work. And technology is transformational. Work is not going away, but jobs are being automated out of existence. The really interesting thing about this data from the World Economic Forum's Future of Jobs 2020 report is that the job functions list for workers in the decreasing demand category is unsurprisingly static. On the other hand, there are numerous changes in the increasing demand category as new jobs have emerged over the past 2 years since their last report. Do you notice any trends in this slide about jobs of the future? That's right. Technicians will need to be comfortable and confident working with data and digital tools. The technician jobs of the future will be what Deloitte calls super jobs. And Burning Glass says in their report, The New Foundational Skills of the Digital Economy, as jobs come to be redefined by new modes of work, the result is a hybridization that mashes together skills from disparate domains and demands greater breadth and flexibility of the workforce. Another way of describing that hybridization's effect on technicians is that some people say technicians are becoming versatilists. Considering that, are there specific knowledge and skill areas that will help future-proof STEM technicians? We would say yes, and that here are the skills that will carry graduates into a secure future of work: data knowledge and analysis, advanced digital literacy, and business knowledge and processes. These categories and their specific subtopics comprise a set of new foundational skills that we call the cross-disciplinary STEM core. So within these new foundational skills, what do STEM technicians need to know and be able to do? Within data knowledge and analysis, technicians need to be able to manipulate, interpret, visualize, compare and contrast, merge, and generally just operate on data to resolve issues and problems. They also need to be able to use Excel and other common software proficiently to accomplish tasks. So here's the list of skills and knowledge that, having worked with subject matter experts and our industry advisory board, we think are the new data use fundamentals for all STEM technicians. Your handout has the definitions for each. You'll notice that some of the items have an asterisk. Those are the topics prioritized by industry. Within advanced digital literacy, technicians need to understand digital communications and networking, the cloud, cybersecurity, machine learning, sensors, programming, and human-machine interfaces at a higher than introductory level. Here are the essential advanced digital knowledge and skills for all STEM technicians, again with an asterisk by topics of higher priority to business. Within business knowledge and processes, technicians need to understand an enterprise, its value chain, and its business practices. Business knowledge also includes work performance skills, as well as an understanding of the ethics surrounding the adoptions and use of new technologies. Because technician jobs generally exist in the context of a business, here are the essential business skills and knowledge they need to function successfully in that environment. Why are these skills critical? In the 2017 report, Jobs Gained, Workforce Transitions in a Time of Automation, the McKinsey Global Institute answers the question by explaining that a core benefit of foundational skills is the capacity to adapt. Having a broader skill base isn't simply about meeting the needs of today's jobs. Rather, these skills equip job seekers and incumbent employees for the future, enabling them to navigate a dynamic landscape of accelerating change, job losses, job changes, and job creation. These three core knowledge and skill areas are essential in today's workplace because they transcend narrow job specialization. Companies can no longer survive with technicians who know how to work with only one or two types of devices. As markets shift and companies adopt new technologies to keep pace, technicians must be able to move laterally to other jobs, learn new techniques, and work with new equipment. Those possessing the broader skills and knowledge found in the cross-disciplinary STEM core will be more flexible in the types of work assignments they can take on, and thus more valuable to employers and better situated for continued employment and promotion. Recognizing this, we have to ask, what is the way forward? We believe the best strategy for adding the cross-disciplinary STEM core into associate degree programs is to integrate relevant lessons into existing courses rather than attempting to add new courses. This strategy would give colleges the flexibility to offer cross-disciplinary content prioritized by regional employers without significant instructional disruption. Integrated lessons help students see the wider perspective of content relationships. For example, as students learn techniques for working in the biotech industry, they should also learn the fundamental concepts of cybersecurity and even of entrepreneurship. This is best accomplished by integrating those concepts into existing biotech coursework in the context of their potential work settings. Stated broadly, programs need to prioritize topics from the cross-disciplinary STEM core, determine where the new topics should go, collaborate with employer partners to create instructional scenarios, provide faculty support, and align skills with employer demand and anticipate the skills of the future. So who has a role in college adoption of the framework for a cross-disciplinary STEM core? To start with, let's look at program leaders like deans and department chairs, technical faculty, and other interested people, like STEM grant PIs, for instance. Their roles include taking inventory of existing program content to determine alignment to the cross-disciplinary STEM core, forming curriculum development work groups, meeting with employer partners to identify priority topics from the STEM core, determining how to infuse lessons that integrate knowledge and skills from the cross-disciplinary STEM core into current content, and providing professional development opportunities for faculty. Program industry advisors and employer partners also have a very important role to play. In activities facilitated by each technical programs team, employers should be brought to the table to prioritize cross-disciplinary STEM core topics and to collaborate with instructors in developing workplace scenarios and project-based learning experiences from their industry experience. Ideally, college presidents are on board with a renewed focus on the future of work and can see the value of championing a systemic approach to preparing technicians for the future of work, promoting cross-disciplinary collaboration and accumulation of STEM core skills across technical programs, and engaging employer partners in meaningful, ongoing dialogue around existing and emerging workforce needs. If the philosophy and content of a cross-disciplinary STEM core for all STEM technicians is something that you're interested in, you don't have to go it alone. Preparing Technicians for the Future of Work has resources, tools, and processes for making integration of the cross-disciplinary STEM core across technical programs a reality. You can reach the project through the website preparingtechnicians.org or contact me directly at my email address. Thank you so much for your interest.